Worksheet, acids and bases. There are several parts to this worksheet. I'll take you through each part one by one. In the first part here, all you have to do is you're going to classify each one as an acid because it starts with an H, or a base because it ends in OH, and then you name each one. So for each of these, write if it's an acid or a base, and then write the name of it. Remember, if it is an acid, you're going to use your acid naming rules that are in your reading materials or also in the notes that you've taken up to this part in the packet. But if it's a base, just name it the way it is because it's just an ionic compound. Number 2, part 2 here, says to complete the equations for the ionization of these acids or bases. So these two right here are going to be acids, and they're going to follow this pattern right here. So as you can see, if I take HBr, which is an acid, and I put it in water, the water is going to act like a base, and it's going to take this extra hydrogen from the acid. So it's going to take the hydrogen from the acid here, and it will become H3O, now with a positive charge because it has another hydrogen atom attached to it. So it's going to have that hydrogen ion attached to it, and so it will now have a positive charge because H has a positive 1 charge, and then because this H has been taken away from HBr, that leaves us with Br with a negative charge because that positive H got taken away from it. So for all of these, just follow the same pattern. The water will gain a hydrogen and the acid will lose a hydrogen to become a negative ion. For our bases, they're just going to break apart into their individual ions. So the potassium here breaks apart from the hydroxide, this having a positive 1 charge, but we can just write a plus instead of the +1, and OH with a negative 1 charge, but we can just write a negative because the 1 is understood. So do the same thing for these, writing the charges of the ions after they break apart. For part 3, this is a little trickier. We haven't done anything like this before. We're going to be looking at the identity of the conjugate acid and the conjugate base in a reaction between an acid and either water or hydroxide in some of these, hydronium and others. So we're going to look at how this reacts to become these products. And because of how these act, you'll be able to tell which one is acting as the acid, which one is acting as the base. So what we're going to do here, look at this example. It tells us that HCl lost an H positive ion to become Cl negative. Whichever one loses the H, all right, in this case HCl becomes just Cl minus, so it lost the H. Because we consider an acid to be what's called a proton donor, in other words, it's going to give away the proton that is hydrogen, then it is going to be the one that's acting like an acid. The proton donor is the acid, so the hydrogen donor, the one that gives away hydrogen, is the acid. So the other one here is going to be the base, and it's the one that's going to gain that hydrogen on the other side. Now that this has lost that hydrogen ion, it's now going to kind of act like a base. So we're going to call it the conjugate base. And now that this one has the extra hydrogen in it, we call it the conjugate acid. And we can see H2O gained the H positive to become H3O positive, so it's the conjugate acid. It now has that hydrogen ion that the acid donated to it. So let's do one of these just so you can see how you're supposed to write it. All I need you to do is put A, B, CB, and CA, depending. So right here I see HNO3, so I'm going to look on the other side to find the counterpart of this HNO3. What did it become? Well, it became NO3 with a negative charge. So because this gave away the hydrogen to become this, I know this is the one that's acting as my acid, so I'm going to put an A here for acid. Then that means this, the water, must be acting as a base. Remember, water can act as an acid or a base, so we're going to put base here. It's acting like a base in this situation. This became NO3 with a negative charge. So this acid became the conjugate base. So I'm going to put CB here. The acid, when it gives away that extra hydrogen, becomes, what's left of it becomes the conjugate base, and the other one will be the conjugate acid because it gained that hydrogen from the acid. So that's all we need to do. Go through the rest of these the same way. Find the acid and the base on the left and label the conjugate acid and conjugate base on the right. Now 4 and 5 are going to ask you to determine the conjugate acid or the conjugate base. In this case, all we do is add an H positive ion. So in this case, we took NO3 with a negative charge. When we add on an H to the beginning of this, right, we add an H positive ion, we put that H in front, and now that we've added a positive charge to go with this negative charge, they cancel out, and we have HNO3. So you're going to do the same thing here. I want you to pay attention to this one because it has a -2 charge. You're only adding one H here, so it's not going to get rid of that entire charge. So be careful when you're doing this one, because you're still going to have more negatives than you have positives. So pay attention to that in your answer. Here it asks what's the conjugate base of the following, and it says what are you going to get by removing that H positive ion. So here we took HBr, take away a positive, and you become one more negative. Since we were neutral at the beginning, we took away one positive, we become one negative here with this Br. So you're going to take away an H from each one and change the charge accordingly. So if you take away a positive, then change the charge to what it should become after you've taken away that positive charge. All right, so take away an H from these, add an H to these, and you'll be done with this worksheet. I know this can be a little bit tricky. It's something we haven't done before, so if you do still have any questions about how to do it, please come ask.